All right, guys, today we're starting a new few days on something called conic sections. And they're called conic sections because each one of these comes from a piece of a cone. So it's called conic sections. The first, we're going to start with this parabolas, and this will be the one that you know the most about already. All right, the geometric definition of a parabola is this. And this was one you may not know. Is a set of all the points in a plane, meaning on a flat surface, that are equal distance from a fixed point, F, called the focus, and a fixed line called the directrix. Focus and directrix. So, look at this picture first. Actually, this one right here. The red, of course, is the parabola. The focus is always inside the parabola, and the directrix is always outside. It's the line down here, that line L that I'm tracing over right here. Each point on the parabola is the same distance away from both. So if you look at that point I just circling right there, it's the same distance to the focus as it is to the directrix. Every point in the parabola, that's what the definition is. There's an axis of symmetry that goes right through the vertex, right through the middle of the parabola. When you know about that already, and you also know that a parabola has a vertex. That stuff you know. Now, a couple other things here. To find the distance between the focus and the vertex, we're going to call that distance P. Also from the vertex to the directrix, we're going to call that distance P. All right, that's going to be P. All right, now here's how we're going to go. This is parabolas that open up and down. If the parabola opens up and down, what that means is our 4P is with the Y. Okay, so think about this. The Y-axis goes up and down, so your 4P is going to be Y. The other side is going to be the squared side. Okay, so either 4P is on the side or the square is on the side. If it's 4P with the Y, it opens up or down. If 4P is with the X, you're going to find out in a few minutes, it opens left or right. The vertex is just 0, 0. The focus is going to be P away. We talked about that on the last slide. The directrix is negative P away, the opposite of P. If P is positive, it opens up. If P is negative, it opens down. And here's the pictures right here. Okay, so there's the point 0P. There's the point 0 P also. And the directrix is the opposite of P away. Let me just show what this is in a problem. All right, so it's found an equation of the parabola with the vertex 0, 0 and focus is 0, 2. And sketch its graph. So if we're going to graph it, the vertex is 0, 0, which is right here. The focus, it says, is 0, 2, which is right there. So the parabola is going to do this. All right, it's going to do that kind of thing right there. And it says find the equation. Well, because it's opening up and down, I know the equation looks like this is x squared equals 4p times y. And remember what p stands for. P is how far it is from the vertex to the focus, which in this case, it's 2 away. So that means p is 2. So if I plug 2 in for the p right there, that gives me 8y. And that's perfect. And it's positive 8y because it's going up. Like this one says, find the focus and directrix of the parabola y equals negative x squared and sketch its graph. Okay, first of all, y equals negative x squared. Because it's negative, the parabola is definitely going down. Just like, hello, it's going down just like that. And also, there's the negative 1 now. Because the square is on the x, I need the 4p on the other side. So I'm going to divide both sides by negative 1, and I get this. I get negative y equals x squared, which means the 4p is going to equal negative 1, because 4p is what is in front of your y. So if I divide by 4 right there, I get negative 1/4, which tells me the focus is 1/4 away from the vertex. So it's 1/4 down. That's why it's a negative 1/4 right there. So the focus would be located at 0, negative 1/4. The directrix is going to be 1/4 above the vertex. That's a terrible line, but it's 1/4 above the vertex. And because it's horizontal, it's going to be y equals positive 1/4. All right, so there's the focus and the vertex. Focus and the directrix probably. Sorry, good night. All right, but key thing when we started right here, your 4p needs to go in front of your y if the x is squared. Remember, the square goes on one side, the 4p goes on the other. All right, now, if the parabola opens sideways, left or right, this is something you haven't seen before, probably. Everything that you know right now is just going to switch. Look where the square is now. The square now is with the y, and the 4p is with the x. The vertex is still 0, 0. The focus is still p0. The directrix is still the opposite of p. The difference here is if p is positive, it opens to the right. If p is negative, it goes left. Okay, so you can, two good pictures down here. You can see focus is still inside. The directrix is still outside. It's still p away. Same thing here. All right, so let's look at an example of this type. Okay, so the parabola has the equation y squared, 6x plus y squared equals 0. Find the focus and directrix and sketch the graph. Okay, so have 6x plus y squared equals 0. Remember, you want your 4p on the opposite side of your square. So there's my y squared. That means this is negative 6x over here. Okay, which means my 4p is negative 6. So if I divide by 4 and reduce it, I get negative 3/2. Okay, there's my p. So let's graph this thing. Vertex is 0, 0. Because my 4p is negative, it's going to open left, so it's going to open this direction. My p is negative 3/2, so I'm going to the left. My focus is 3/2 away, which is 1.5, so it's right there. That's the focus. So that means my focus, you need to label it here. My focus is negative 3/2, 0. My directrix is going to be 3/2 the opposite way. I'm having a hard time drawing lines today, as in every day. So the directrix would be x equals positive 3/2. Okay, 3/2 away in the other direction. Hope you're finding this isn't too hard at all. It's really a different way of doing parabolas than you've done before, but to be honest, it's probably a better way. Okay, weird word here, hang in there. Okay, the line segment that runs through the focus, perpendicular to the axis of symmetry, with endpoints on the parabola is called the lattice rectum. You read that right, the lattice rectum. I'm just going to leave that right there. The length of the lattice rectum, still going to leave that right there, is called the focal diameter. I just had a thought, and I'll tell you that tomorrow. Focal diameter of the parabola, the way to find the length of the focal diameter is, or the lattice rectum, is the absolute value of your 4p. That's all you got to do, the absolute value of the 4p. That is the length of the lattice rectum, which is called the focal diameter. Let's look at one of those when we're done. All right, so let's find the focus, directrix, and focal diameter of that parabola. Okay, now this parabola, and let's just sketch the graph. This parabola is starting out like this. Our problem here is our 4p's on the wrong side. Remember, the square goes on one side, the 4p goes on the other. So I'm going to multiply both sides by 2 to get the 4p on the side I want it on. Also, because the 4p is with the y, that means it's opening up and down. So vertex is 0, 0, and it's going to go up. It's going to go up. So 4p equals 2, which means p is 1/2. Means my focus is up half in the vertex. That means my focus is the point 0, 1/2, which means the directrix is 1/2 below. I'm going to try to get one good one here before the video's over. That's close, which is y equals negative 1/2. And it's going to ask you for the focal diameter. I'm just going to put FD for focal diameter. Now remember what that is. The focal diameter is the length of the lattice rectum. By the way, the lattice rectum is going right through here. It goes through the focus, perpendicular to the axis, which goes right through here, and it endpoints on the parabola. So wants to know how long is that? That's what the focal diameter is. And remember, it was the absolute value of 4p. Our 4p is 1/2, so this is also 1/2 is our focal diameter. All right, hope that makes some sense. We'll do a bunch of these tomorrow. Can't wait to see you. Adios.